Hello again, YouTube. This is going to be a quick one. There's going to be no code. As you can see, we don't have any electronic device at all in terms of development, so there'll be no code. This is, as you can see, Victron Energy MPPT, which is a solar charge controller. Last week I did, or the last episode, I don't know when it was, but last episode I touched on the RS232 serial protocol and said that it was invented or first appeared back in the 1960s. I've since, I decided I better check that, and it was actually as far back as 1960 itself it was introduced, so it was I quite surprised, in spite of its age and being a 1960s communications protocol. It's still in use today, so you will still see it in a lot of places. So this solar charge controller actually has a little JST connector. You're not going to see it, it's not going to be focusing, but that is a serial connection, and a lot of products you might have to reverse engineer that, but Victron Energy have kindly given us information about their protocol, which their products communicate. So some of their products use different protocols. Some use Modbus, I assume, over RS485. Some use CAN bus, but this is a very small solar charge controller, 15 amps limit, so a small product. It's simple for them to just use a serial interface. So you've got this pinout is described here, and very conveniently has the pinout for the ground, the power as well, and RX and TX. So all we need to communicate with this, and it gives you the information that you need in terms of, now we could reverse engineer that by putting on a logic analyzer and looking at it. We might actually do that. Well, give us a minute. But in addition, they've got all the messages that are coming across. So all of the various pieces of information which this MPPT can tell us. So there's other products in their portfolio of products, but this is what the various messages. So you can see the MPPT was this column. It supports H19 field, which is the yield total. H20 is the yield today. So we've all these little pieces of information. So to see these, Victron Energy also give us accessories, as you might imagine. So for example, they will sell you a Bluetooth dongle. So the Bluetooth dongle will simply plug into that serial connection. And if I find my phone, there is, I better turn on Bluetooth. So then if I make room, I better focus this a little. I'm doing manual focus because it sometimes annoys me what the computer or the camera tries to focus on. I'm sure it's that's not very reassuring, is it? It's about 5 centimeters away and it still can't communicate. There we go. So as you can see, this is a more kind of, I suppose, possibly user-friendly visual interface to the actual solar charge controller. So you can see that it's generating a miserable 3 watts of electricity because this is another one of those cloudy days. And I'm only to just have a small panel on it just to test this out and see what it does. So that's the interface to the device, the solar charge controller. But we can, I've actually taken, if I get rid of that, I've also, as well as getting this Bluetooth dongle, which plugs in, now that's the connector is a simple JST connector. I think it says that in the document there. If you go down through all the protocol stuff, it gives you some indication of, so it's a JST PH 4-pin connector. Now I could have actually gone and got that connector, but I bought, I actually bought, as well as the Bluetooth dongle, I bought a the Victron Energy's cable, which has got, there's a number of cables. They've got USB ends, they've got 9-pin serial connectors, RS232 connectors, but I bought this one and chopped it so it had 2 JSTs, and I just put a DuPont on the other side. So I've got I've now got access to all that information, the serial connection, the RS232, via this little DuPont connector. Now that cable was never intended to be cut, obviously, because in this cable the red is the negative and the black is the positive, which is kind of the reverse of what you'd expect. But as I say, it was a cable that was made sealed, and it just did pin 1 to pin 1, pin 2 to pin 2, etc. And it was never intended to be used as what I'm using it for. So now that we have that, I had originally intended putting this onto, as an expansion board, onto the cinnamon bun. Like I have been playing in the past with a couple of LEDs and a switch, and I was going to play about then with this serial connection, which we can still do, but there's one slight issue. If you look at that's determined to sit the way it wants to sit. I'll leave it. If you look at this document, there is a frequently asked questions for the VE.Direct Protocol, and I'm not sure if this applies to all their products, but it is the frequently asked question, so I suppose we better respect it. And one of the questions is, how much current can we draw from that port? And the answer is a maximum of 10 milliamps, which is a bit less than the cinnamon bun is going to draw. So you'd have to self-power. You'd have to self-power the cinnamon bun, so that kind of like removes the whole point of it in a way. If you were putting this in a remote location in the field, you don't want to have power running to a monitoring device as well. So I might try and use a different processor or microcontroller to talk to this device. But I just thought I'd go over this for the minute just to see what it's given you. And we could use a protocol analyzer. Actually, why not? This is a cheap a very cheap logic analyzer. You get it off the web, off eBay or whatever, or some of the AliExpress or Banggood or something. There's a very good description of it in YouTube channel, Open Tech Lab. I'll put a link in the notes for this. But there's a very good introduction to these little products and what they can do. So let's look at what this thing is producing, and we'll do this with PulseView, which I probably don't have installed. PulseView is the front, it's a graphical user interface, it's the front end to SIGROC. So we'll try this again. Unbelievable. Has it not? Maybe it hasn't installed. It never installed SIGROC. It usually installs dependencies. I'm kind of surprised that it didn't. Yeah. So if we look at our device, which is, that's funny. Having said that, I'm using the USB cable, which is not the best. That is strange. Hold on. I shall dump that USB cable. I've been meaning to do it for a while. And I have no excuse. The USB cable that comes with it, Pick Kit 3, is actually a good. I'm going to have to do this again. There we go. I don't know what it's doing. Right, so if we go to Silly Logic device, and we've only got two. I've done 0 and 1. And run that. Now there we go. You can see bursts of activity here. Now if we didn't have the information from the actual documentation from Victron Energy, we could actually look at this, determine what get the minimum, the smallest little pulse, and work out what frequency we're running, get an idea of what the start and stop. I need a better mouse. What the start and stop bits are and all the rest of the protocol. But we don't need to do that because we have the documentation. So that's PulseView. Like I say, Open Tech Lab, I'll put a link in the show notes. The other thing obviously we can do, because we know that the communications, we can do what I did the last time, which is a Kermit. And we'll do that into I just get rid of this. This Silly Logic. Sorry, that's stopped recording. Ah, brilliant. So what we used the last time was this little Raspberry Pi serial cable, and if I put this in, seems determined not to want to go into a serial connection, but so I'll plug in the ground, and yellow is a receive. We won't bother with transmit for the minute. So then we can go to and just set the speed of this connection to 19K2, and we have to set carrier watch off. I must install Minicom. Now I've got that on the wrong pin, obviously. Excuse me a moment. So now you can see the protocol as it's documented there. So it's spitting out a record pretty much every second, and that is obviously ASCII readable text because it's human readable. Now I haven't got into the other protocol, but the other protocol in here is a hexadecimal based protocol, which is not human readable. So once you plug in a device, like if you plugged in a Raspberry Pi or Arduino or something and started communicating with the MPPT solar charger, then you could communicate with a hexadecimal. Now I'm waiting for, there's a hexadecimal there. So you can see the normal ASCII based record goes down as far as this checksum and then starts again. So we've got all the various fields that document told us it was going to give us. So we've got, what did I say, H20 was the yield for the day in 0.01 kilowatts. So our yield for the day H20 is 2, a minuscule 2, and this is the ASCII record. So every so often, yes, it's an asynchronous. It just the MPPT just spits it out every now and again, the hexadecimal protocol, as well as the regular 1 second ASCII. But once you start communicating with the device, if you've plugged an Arduino in or a Raspberry Pi or something, once you start talking hexadecimal, then the solar charge controller will stop spitting out the hexadecimal every second, because that would interfere with communications. So that's a simple introduction to this device. Now I might actually test to see how much current is being drawn from this, but it might be the focus of a couple of projects. So I just thought I'd give you a brief introduction to this solar charge controller. And like I say, RS232 serial communications was born in the 1960s, but it's not dead yet. And it's a very simple interface. It's tried and tested, and if you haven't got a huge amount of data to transmit between two computers, then it's easy, it's very convenient. I'll leave it there. Very short video. Thanks a million for watching.